Welcome to the Rocket Science 101. Today we are going to talk about combinations of ducted jet engines and rocket engines. In episode 3, we explored how rockets carry their own oxidizer and break free from Earth's atmosphere. But chemical rockets are only the beginning. Engineers have pushed the limits with new ideas, some flown, some still experimental. Hybrid rockets. Hybrid rockets combine the best of both worlds, part solid, part liquid. Imagine a chamber packed with solid fuel while a stream of liquid oxidizer is injected into it. The result is a safer, controllable engine, simpler than a liquid rocket, but more flexible than a solid one. They can be shut down and restarted unlike solid rockets, and they avoid some of the complex plumbing of liquid systems. Examples include experimental vehicles by Spaceship 1 and Spaceship 2, which used hybrid motors for suborbital space tourism. Another example is NASA's tests of paraffin-based fuels, showing high performance and safety advantages. Hybrids have also been proposed for future lunar landers and sounding rockets. Combinations of rockets and jet engines. Sometimes engineers combine rocket and air-breathing engines in one system. The US Tomahawk cruise missile, for example, uses a solid booster to launch it from the ground, then switches to a small turbojet engine for sustained low-level flight. Other concepts include the air-augmented rocket, which mixes atmospheric air with rocket exhaust to increase thrust efficiency within Earth's atmosphere. The integral rocket, ramjet, is another clever design, first acting as a solid rocket booster, and once the propellant is consumed, the same chamber transitions into a ramjet using incoming air. Examples include experimental French and Russian air-to-air missiles, as well as US projects exploring air-augmented rockets for high-speed flight. These systems aim to reduce fuel consumption while extending range. Hybrid rockets and rocket-jet combinations represent the bridge between traditional chemical propulsion and the innovations of the future. They balance safety, performance, and versatility. These stories showcase how engineers continue to expand beyond the classic rocket model, experimenting with designs that take advantage of both stored propellants and the environment around us. Thanks for watching. Stay tuned for the next episode.